Till now we have looked at functions like this. Now here we have only one variable. So it's a function of one variable. But suppose it's a function of two variables. Say the two independent variables are x and y. So let's say 3x squared plus 7y cube, let's say, just to make it interesting. Now when we had to differentiate this, we used to say dy by dx of 3x square is 6x. There we were confident that there is only that the function is going to change only with respect to x. But here it can change with respect to x or it can change with respect to y. So that means we might have to differentiate it with respect to x or with respect to y, or both may be changing. So there are a little bit complications. So the way to look at this is these two are x and y are independent variables. So which means that they both don't depend on each other. So a change in x doesn't mean that y is going to change or vice versa. So when x changes, we assume that y is constant, or when y is constant, we assume that when y is changing, we assume that x is constant, even if both are changing. Remember, this is only with respect to differentiation. Okay. Now, since this complication has arrived, we can't just use dy by dx, because then it doesn't convey the idea that this is not a proper differentiation, but only with respect to one of several variables. For that, we have the notation dou. So dou z by dou x. So this means that we have to differentiate with respect to x. That means x is changing. So here what happens? We assume that y is constant. That means the whole term, second term becomes constant, and differentiation of constant is 0. This becomes 6x. Similarly, dou z by dou y becomes 21y square. Now, just like single variable functions, we can differentiate this again. D square z by dou square z by dou x square. So this becomes 6. Again, dou cube z by dou x cube equal to 0. Here dou square z by dou y square becomes 42y, becomes 42, and finally equal to 0. Now it might happen that when we are trying to differentiate it the second time, we might want to differentiate this with respect to y, but since y is not there, it's not going to change, right? It doesn't matter. But what if the function is something like this? Let's say z is equal to 3x square y plus 4xy square. Now here none of the terms disappears when we differentiate it. Here y was disappearing and here x was disappearing. Here they will not disappear. Let's see. Dou z by dou x with respect to x. So which means y, we assume it is constant. So when we differentiate it, this becomes 3y because y is constant, and x square differentiation is 2x plus 4y square times 1, which is equal to 6xy plus 4y square. Similarly, dou z by dou y. if we differentiate it with respect to y. Now what happens? 3x square is constant and differentiation of y is 1, plus 4x is constant and y square differentiation is 2y, which is 3x square plus 8xy. Okay. Now, if we have to differentiate it again, now we have a choice, right? Dou z by dou x can be differentiated with respect to either x or y again, right? So, which means that can be dou z by dou x can be differentiated with respect to x again, which will give us what? Y is constant, so this becomes 6y times 1 and 4y square totally disappears. So we are left with 6y. Now dou z by dou x, we differentiate it with respect to dou y. Now what happens? We are left with 6x times 1 plus, from where did this minus come? It should be equal to, okay, 6x, x constant because we are differentiating with respect to y, and 8y. Okay. Now dou z by dou y we have already differentiated. Now we can differentiate it with respect to x. So what do we get? 6x, 3x square, 6x plus 8y, and dou z by dou y we can differentiate it with respect to y. When we differentiate it with respect to y, the first term disappears and the second term becomes 8y multiplied by 1. We don't need to write. So we'll remove this. Now do you notice something interesting? These both are equal. Yes, 6x plus 8y. That means what? At least in this particular example, dou square z by dou y dou x is equal to dou square z by dou x times dou y. Of course, in this example only. But as we explore it further, we will realize that this is a common thing. It's like a rule that it will always be equal. That means they are second order derivatives are independent of the order of differentiation with respect to x and y. So it doesn't matter in which order you do it, you will get the same result. Yes. Now, of course, when you are practicing, this is how usually the questions would be. Given a function, prove that dou square f by dou x dou y is equal to dou square f by dou y by dou y times dou x. So dou square f by dou x dou y is equal to dou square f by dou y dou x. Prove this for a given function. So which means anyhow you have to do partial differentiation with first time, then you'll have to do partial differentiation the second time. So automatically you will get practice for partial differentiation. Okay, now that you got the idea, in the next session we will do many exercises. Enough for today. Bye for now.